And I'm Jeannie Patton. I am the communications lead for the Nature Conservancy's Landfire Team, and welcome you to our first in the series for the Rocky Mountain region, Northern Rockies and Southern Rockies Fire Science Network's three-part webinar series. So we'll do a little housekeeping first and then turn it over to Randy. We will not go over time. We are recording, so please put your phones on mute if you would. That's *6. And open up your chat window, if you would. You can do that by just, there's a little drill down at the top and open up chat. We'd like you to keep that open and send your comments to everyone. We let you to ask your questions during the presentation, make your comments during the presentation. Both Randy and I are going to be monitoring, and we want to be sure that we get your questions answered and we can avoid some duplication if need be. So I'd like to give you a little bit of information here about where we're going on today's presentation. First of all, who our partners are. So the Landfire Group and the Joint Fire Science Program have put together this series of webinars this year. We're moving our way across the country. We started in the West with the Pacific Northwest group called the Northwest Fire Science Network. We have done this presentation, Landfire 101, with those guys, and we're going to launch into assessing needs next. Want to let you know that each of the series is following the same format. So we are going to be doing Landfire 101. This means that if you know people who are missing 101, they have a couple of options. They can join another one or they can see our recording. Our second webinar is a case study or report that is focused in a consortium or network geographic area. In the Pacific Northwest, we grabbed one of those. Today you're going to see some Rockies work. And then the third one, we're going to be doing customizing data for your specific landscapes. Because there are so many options to customize data, we're going to pick out one or two and give you some examples of how it can happen. So once again, we're recording all of our webinars. They're available. You can sign in for anyone across the country. From the Rockies, we'll move to the Midwest and work our way across. So if you have any questions for us, send them to me in the chat window. I'll pick them up, and welcome to our presentations. Randy, I'm going to turn this over to you now.
Great. Thanks, Jeannie. And thanks, everyone. This is Randy Swaty. I'm an ecologist with the Nature Conservancy's Landfire Team. I live in Marquette, Michigan on Lake Superior, though I've tromped around the Rocky Mountains a fair bit and really love where you guys live, so I'm really pleased to get to talk about Landfire with you all today. And again, as Jeannie said, I'll encourage you guys to comment, question, everything through the chat window. I'll be watching that as we go along, so I really want to invite you to participate and pass along your thoughts. Today I'm hoping to inspire you to think about Landfire data, models, tools, and approaches almost as an example of the broader science work going on across the country. Data is just proliferating like crazy. There are data nodes and data centers, data repositories, and so it's an exciting time to be in science, especially in the landscape scale sciences where the tools are just amazing. So hopefully I'll inspire you today. As we like to say, Landfire is about more than fire. I know all of us on the call today, are driven by fire-adapted ecosystems, but I want you to think about Landfire in terms of vegetation, fire, and fuels, all of it together. So we do have some nuts and bolts to cover, so if you're kind of a science geek and love data, hopefully that will inspire you to get into Landfire. If you're not so much of a geek, put on your thinking cap, and we'll see what we can come up together to help us restore and manage these ecosystems. All right, so what is Landfire? I'm going to try to present this a few ways. It's really hard because I don't want to limit us in our thinking because Landfire is a huge thing, so I'll go into this a little bit. It's a partnership. I want you to take that away. This official statement captures part of the community that makes up Landfire. There's academics, private consultants, students, NGOs, agencies, people across the country are all contributing, and contributing with an ing there. It's always growing and changing and progressing. Here you see maps in a model schematic. This is also just part of the story. Landfire is about people, ideas, and making the most of the current products available to us. People are doing creative things all over the country to match the data that we have with their own data, to adapt and do what they can to make sound management decisions. Also note the word vegetation. As I mentioned, Landfire is partly about solving fire-related issues, but also about broader vegetation and values that are connected to it. Here's another attempt to describe it. Probably too much text there, but it's the official language in a quick story. My first job out of graduate school was working to help large industrial landowners here in the Upper Peninsula of Michigan talk to each other and cooperate at a landscape scale. They all had, really robust inventories and processes for management within their organizations, but they didn't work across ownerships, and part of the problem was antitrust laws. They couldn't share data. So they couldn't think about the broader landscape. They had this checkerboard of ownership, but everything was managed as a checkerboard. As a mycorrhizal ecologist in school, I assumed that we had all the basic ecological data we needed to deal with these situations. I thought we had the maps, the ecological descriptions that spelled out how ecosystems would look and work naturally, but I was wrong. Lots of information was out there, but from disparate sources, sometimes confidential, always incomplete. So when I heard about Landfire, I was excited. A project aimed to facilitate landscape-scale planning through data development and much more. I am amazed by the large data sets and descriptive projects we're putting together, and I think they can make a real difference in large landscape management. All right, so I'm probably starting to sound like a politician because it is really hard to describe exactly what this thing Landfire is. Here's the reason I'm being vague. If I told you that Landfire was just data or models, I think I'd be limiting us, and I don't want to do that. And I'm kind of sick of the toolbox analogy, so I'm going to try a new one on you. Think music, and let me know how that works. Our experiences from music, range from being stuck on an elevator with a jingle that we can't shake all the way from being moved by live music. Maybe a jazz musician mostly improvising. Landfire can be like this. Some of you are no doubt feeling stuck with Landfire data if you're doing some of these large-scale fire program analysis sorts of things, and you wish you could use more local data. That would be the elevator music analogy. But some of us can be really creative, and while we need to stick to the scales or time signatures of science, Landfire can provide a lot of room for improvisation and making some tools and analyses that will help us with land management. So, yeah, let me know what you think of that analogy. I'm trying to move past the old toolbox one. All right, so you may be wondering what the Nature Conservancy's role in this is. We worked on describing reference conditions for the country. That was our main role in the Landfire project, or the main development phase of Landfire. And I bring this up, I want to separate out the aspatial and spatial products of Landfire as we go through this. And so I'm going to drill into what we call models. So in my mind, Landfire produced the country's first encyclopedia of ecosystems. Landfire, working with hundreds of experts in dozens of workshops, described how the ecosystems of the U.S. looked and worked prior to major European settlement. We described the ecosystems, then modeled disturbances to get an estimate of how much each developmental stage or succession class would be on the landscape. These descriptions and models were then reviewed, QA/QC'd, and are available to you here on the link below that we'll provide to you later in a way that you can grab a hold of. So the models look like this. We used VDDT, or Vegetation Dynamics Development Tool, which has been since replaced by a software called SynchroSim, we entered the parameters of the succession classes represented in the green boxes here, up to 5, the natural disturbances that would affect each one of those succession classes and their impacts. The natural disturbances include multiple types of fire, such as surface or replacement, wind, flooding, insects, and can also have user-defined disturbances such as beaver herbivory. The state and transition models quantify rates and pathways for succession and the probability of disturbance under the reference conditions. These models that you run in SynchroSim or VDDT, two free software tools, are accompanied by a description document that describes the site characteristics, species, geographic ranges for each biophysical setting or ecosystem. And so they're a wealth of information, and people across the country are taking them and customizing them. And in this next slide, I'm going to go into a little more detail of what this all means. So the reference condition models and documents are used in multiple ways in Landfire, including calculating vegetation departure, formerly known as Fire Regime Condition Class, or FRCC. Here's a representation of how this works. The BPS models, or biophysical setting models, estimate how much of each succession class would be on the landscape with natural disturbance regimes. And on the graph, you see that represented in sort of the light gray bars on the left side of each pair. Each succession class is defined by species, canopy height in meters, percent cover. And you can see that with this western hemlock ecosystem, farther west than you guys. I'm sorry, I forgot to grab something a little more local, like a ponderosa pine ecosystem. But historically, there would be roughly 70% of the landscape in the tall, closed canopy succession class that you see on the right side of the graph. Landfire maps where the succession classes are currently. To get vegetation departure, Landfire uses a fairly simple method that generates a high number where the current percentages of each succession class would be different from reference percentages, a low number where the ecosystem is similar to reference conditions. So here you see the taller succession class is underrepresented on the landscape and the shorter succession class is overrepresented. And here the fine print, you know, this is for context on your landscape. We are not saying that reference conditions are necessarily your desired future conditions. This is not a prescription, but it's background information to help manage your landscapes and to understand how they would normally work, your ecosystem. So we understand there's climate change, resource extraction, invasives, several things. So it is possible to go in to these models and add those modern disturbances in and project out into the future. So call us if you're ever interested in checking that out. So here's what that website looks like. And again, we'll share that with you. But at landfire.gov, you can drill down into this page. And you'll see that there's a U.S. map with map zones. And that's how the descriptions and models are delivered. So here's sort of what it looks like. The model descriptions are delivered as an Adobe Acrobat PDF file. The actual models are in an Access database to be run and manipulated in that free software I mentioned earlier. So you have the descriptions as a PDF file, and the models run off of an Access database. So to summarize these models, or one of the 8 spatial data sets I wanted to talk to you about today, they represent how the ecosystems of the U.S. worked prior to European settlement. There's a model and a description, kind of 2 parts. And as I mentioned, they're not a prescription, and these models can be hacked and modified. So with that, I'm going to pause for just a moment and see if you have any questions that you want to type in.
And this is Jeannie. I'm going to jump in and say that our friends who are working on Macs may or may not have chat windows available to them depending on the browser you're using, et cetera. So if you're using a Mac, unmute yourself, jump in with a question that you can ask Randy live, and then the rest of us will use the chat windows.
Okay, thanks, Jeannie. Okay, now I'm going to jump into some of the spatial products. Oftentimes when people think Landfire, they think of the maps and the spatial products. So here's a partial list of the data sets that are available, sort of grouped by vegetation, fire regime, fuel, and disturbance. So I'll be demonstrating some of those later today, but I wanted to point a few of these out to you that I really use a fair bit. For example, there are some topographic data sets such as aspect, slope, and elevation. Those are some of our most downloaded and used data sets that actually aren't listed here. So you can get those for large areas. In the vegetation group, you see we map not only current vegetation, but show several potential vegetation concepts. So we have existing vegetation type, height, and cover. We also map biophysical settings, and that would be the historic ecosystems where they would occur based on superficial geology, climate, aspect, slope. Being in the Midwest, I almost forgot to mention slope, aspect, and elevation. Ours are driven by soils mostly. You also see that there's a fire regime sort of group, and under that would be fire regime groups, which represents historic fire severity and frequency. And you can get data such as mean fire return interval, again, modeled historic. So from that, you can get a picture of how your state or your landscape, your ecoregion would have burned historically, how often there would have been a fire. Under fuels, you see that we map all the layers required to run common fire behavior modeling systems such as FarSight and FlamMap. And for our updating process, we now have a new disturbance product suite that maps the location of natural and human-caused disturbances that you see at the bottom right. So some characteristics of the data that I want to point out. Landfire data is wall-to-wall, and this map doesn't show it, but we also map Hawaii, Alaska, and the Insular Islands. The spatial data is integrated, meaning all the data sets work together. So you can mash them together without having to do heaps of crosswalking or manipulation. The data is delivered as 30-meter pixels, so it's designed to use across large areas. And I apologize if you're red-green colorblind. Okay, so I wanted to spin through a few of the data sets. As you see here, these are the map zones. Landfire data delivered in map zones. And in the next few slides, I'll just show you some data I prepared for an ecoregion in your neighborhood. Here's Landfire existing vegetation type that I made for the Rocky Mountains ecoregion. This data is designed to represent nature-served ecological systems, which is an attribute table. For this map, to keep it simple, I picked a broader classification in the data for the legend. So these are the MVCS subclasses. The attribute table is fairly comprehensive. There are several ways you can display the data. Here's Landfire 2010 Scott Bergen fire behavior fuel models grouped by fuel model type. Again, the full set of 40 is mapped, though I lumped for clarity in the legend just so it wasn't a 40-item long legend. Here's that historic mean fire return interval data set I mentioned. Using our models and a little creativity, you can get estimates of how many acres would have burned annually for an area such as the state, for example. I know it's kind of paltry, but for example, calculated in Michigan, we would have had between 1 and 1.5 million acres of fire annually under a natural disturbance regime. So we can do that sort of work for your state or your place. All right, so summarizing the spatial data, we have dozens of 30-meter pixel raster data sets designed for large landscape analysis. And as I mentioned earlier, one of the most used data sets is the topographic data set. You can grab it and use it for a large area, so it makes it fairly easy to use. And with that summary, I'll stop once again for just a few seconds to see if there's any questions for those that are on a Mac and can't chat, or if other ones want to type in a chat question. Okay. So Landfire, as I mentioned, is not static. It periodically updates its products. This table provides an overview of the major versions. So Landfire National would be the original data sets delivered, roughly in 2009, that represent year 2001, roughly. In 2001, we improved some methods for mapping existing vegetation cover and height and fixed a few other issues around the edges. In 2008, we updated the products using change detection and information on disturbance and succession to a circa 2008 condition. Landfire 2010 is similar to 2008, but brings the map products up to 2010 condition. And I'll go into this refresh process a little bit more in the next slide. So Landfire used many methods to update the data. So in 2008 and 2010 and in the upcoming 2012 data sets, it's not a total remap of all the data sets, but a refresh process using change detection, for example. Excuse me. For Landfire 2010, the program analyzed roughly 4,300 Landsat scenes for change in the conterminous U.S. alone. Wildfire databases were used for mapping disturbance, so databases such as the burned area reflectance classification, the rapid assessment of vegetation condition after wildfire, the burned area emergency response database. Wherever we can get fire data, we use it. Events from users such as yourself. So Landfire 2010 added over 200,000 disturbance and treatment events to the almost 600,000 events mapped for Landfire 2008. So it won't be long before we'll have over 1 million disturbances mapped. These sources of information are used to generate the Landfire disturbance map, which identifies all the areas we have found where there has been a change. The type, severity, and data that changed is used as input into a vegetation transitions database that uses rule sets to determine the effect of that change. So, for example, if in the original Landfire National data we had a ponderosa pine forest, then in 2009 there was a replacement fire, those pixels might be remapped as a herbaceous type if the canopy was totally removed based on the disturbance. Also, the percent cover would be changed. So in that example, you may have had percent cover of 80%, and after the fire it was reduced to 10 to 20. That will be changed in the new data set. Changes in the trio of the existing vegetation layers, type, cover, and height, are then used to inform changes in related products such as the fuel models and succession class layers. Also, in 2010, Landfire included some of the U.S. insular areas. Importantly, these maps for the new geographies are not a refresh or an update, as Landfire had not mapped these areas before. These areas will get new maps based on circa 2010 imagery. So I hope you've gotten the picture that Landfire plus users equal better products. And we really count on you guys for plot information, for feedback. The importance of the user community cannot be overstated. In addition to the disturbance and treatments events, here's an example of how important users are to our mapping effort. We have over roughly 820,000 georeference plot locations, many of which came from the user community. These plot areas help train our imagery processing. So it basically works like this. The more plots and information we have for an area, the better the maps turn out to be in the end. They're really the foundation of our maps. In addition to providing plots, users can provide feedback. To the extent possible, we incorporate user feedback to improve our maps, not just update them over time. Improvements to forest height and cover that were incorporated into the 2001 update were a result of feedback, possibly from you. So please submit any plot data you have that's georeferenced, disturbance information, or feedback. So across the country, as I've mentioned, people are using Landfire data in many ways. This map shows a sampling, by no means complete, of projects, assessments, studies that have used Landfire data and concepts. So if you want to, on your lunch hour or some other time, go into the WHAM, my favorite acronym, standing for the Web Hosted Application Map, with an exclamation point, of course. One of our goals with this map is to transfer lessons learned from the user community. Users are always innovating, working around data issues, and combining data sets in novel ways to answer questions that we never considered. You can check it out at this address here. Every orange dot on the map takes you to a short description of the project, which includes links to more detailed information. All right, there are more places to get information, including the Conservation Gateway. The Nature Conservancy's Landfire web presence is online at the Nature Conservancy's Gateway site here. We offer a broad selection of resources, so you can see from the screen cap and left resource headers the way our products and information would be organized. We continually update the material, adding to holdings and resources, so check back often, and provide us your stories of how you use Landfire. It's relatively user-friendly and light on its feet, and here are some summaries of the different pages and what people use the most, according to Google Analytics. The Gateway site works in concert with Landfire.gov. It's not the engine that runs the software, tools, and data. It's the quick access, succinct, regularly updated guide to facts, scenery, and stops. And, you know, I've kind of just touched on Landfire.gov, but also when you want to learn about the basics of the data, the program, and documentation, go to Landfire.gov. It's been recently updated, and it's a really deep, rich website as well, delivered by the Landfire program. So in summary, Landfire is a huge repository, a living program, a community that delivers reference models and descriptions, spatial data, probably hundreds of research projects now across the country, tutorials, documentation, and updates. And as I mentioned, I'm representing the Nature Conservancy's Landfire team. We are not the whole Landfire program by any means. There are people with the Forest Service, USGS, several contractors that are working incredibly hard to make the data be the best it can be, to update the website. But here are the 5 members on the team. That's the Nature Conservancy's Landfire team. We have Jim Smith in Florida, Corey in Oregon, myself in Michigan, Sarah in Minneapolis, and Jeannie in your neck of the woods there in Boulder. We've got a wide range of experiences on our team, so do feel free to call us. And for more information, here are the main links that I wanted you to have. And these will be available. Jeannie will make all these available to you later. And with that, I want to invite you all to ask questions, comment, provide ideas, stories, reactions to Landfire or the presentation today.
We do have a question about where is this going to be posted, our recording, and it will be posted on the Landfire YouTube channel. You see a note there that the keyword is Landfire. You pull us up, and everything that we record through the series across the country will be posted there. Those that we are working with in the Northwest Fire Science Network have their own site, and if you go on to our Conservation Gateway, you can see it as the second link there. We also post the links there. So if you just get to the gateway, you'll be able to get to our recordings, no matter where they sit.